What if the foundation of everything we thought we understood about our solar system was fundamentally incomplete, missing a colossal, invisible force lurking in the vast, frozen depths beyond Neptune? For decades, astronomers have entertained whispers of an elusive Planet 9, a hypothetical body so distant, so dark, that it has remained undetected despite the sharpest eyes in the cosmos. The idea was relegated to the edges of speculation, the province of theorists and dreamers, a placeholder for strange gravitational anomalies that defied conventional explanation. But today, that whisper is no longer faint. A silent behemoth may be calling out from the abyss. A revelation has emerged, not from a telescope aimed at our neighboring stars, but from a machine designed to look far beyond them. The James Webb Space Telescope, JWST, humanity's most advanced eye on the universe, built to study the dawn of time itself, has inadvertently stumbled upon a mystery much closer to home. Assisted by a revolutionary quantum AI system capable of processing and decoding petabytes of data, JWST has unveiled something staggering, an anomaly at the edge of the solar system, too consistent, too coherent, and too massive to ignore. It started innocuously. JWST's deep-field infrared surveys were meant to chart the ancient light of galaxies billions of years old. Buried within those streams of data, something unexpected began to take shape. Infinitesimal distortions in gravitational fields, slight but consistent ripples in the alignment of distant Kuiper belt objects, subtle fingerprints of an unseen hand shaping the outer architecture of our solar system. These clues, obscured in the noise of countless observations, eluded traditional analysis. But when researchers turned to the cutting-edge quantum AI, an algorithm built on principles of quantum entanglement and probabilistic pattern recognition, it read between the pixels. Rather than just scanning for light, the AI inferred gravitational structure, mapping the invisible tug of mass through its effect on surrounding objects. And that's when the impossible began to emerge. After 72 hours of unbroken analysis, quantum computation humming silently across multiple dimensions of inference, the AI produced a definitive result. Anomaly confirmed. Candidate object detected. The announcement sent shockwaves through mission control. This was not a glitch, not a mirage conjured by statistical chance. It was real. Something enormous was moving at the margins of the solar system. Something slow, cold, and heavy. As scientists delved into the data, the picture became clearer. The object was estimated to be between 5 and 10 times the mass of Earth. Far, too large to be an asteroid or dwarf planet. Its orbit was wide, stretched, and steeply inclined, matching almost perfectly the theoretical models proposed for Planet 9. But while it fit the models in shape and scale, its thermal signature raised deeper questions. Unlike a typical gas giant, the object emitted very faint, uneven heat, a low rhythmic flicker that pulsed like a heartbeat. Not just cold, but alive with variation. Its gravitational field also exhibited subtle oscillations. To some scientists, this suggested an accompanying moon or a ring system. But a growing number of experts offered a more exotic hypothesis. What if the object wasn't a planet at all? What if it were a primordial black hole, an ultra-dense fragment of the early universe, no larger than a city, yet containing the mass of several Earths? If true, this would not just rewrite planetary science. It would upend our understanding of cosmic history itself. A black hole, ancient and forgotten, hidden for eons in the solar system's deep freeze. The implications were staggering, and yet even this idea may not be the most extraordinary. Because as analysis continued, something stranger emerged. The AI had isolated a narrow-band infrared signal, a regular, repeating pulse. At first, this was dismissed as a computational artifact, a sensor anomaly, or a mundane atmospheric effect. But after repeated verifications across multiple observatories and recalibrations of JWST's instruments, the pulse remained. It was real. It was timed. It was structured. Could it be tidal heating from a gravitational interaction? A resonance from internal planetary dynamics? Perhaps. But a small, persistent faction of researchers began to explore a more unsettling question. Could the signal be artificial? Was it a beacon? A machine's dying breath, or worse, a message? A rhythm engineered by intelligence long since lost to cosmic drift? To suggest such a thing is, of course, speculative at best, but history is filled with transformative discoveries that began as heresy. And the signal's consistency is difficult to ignore. Its frequency follows no known natural harmonic. Its strength does not decay in accordance with random emissions, and most perplexingly, it appears to modulate, its intervals adapting subtly over time, as if responding to something or someone. If this is true, if this object is not just a rogue planet or a fossilized black hole, but the remnant of an ancient intelligence, then we have not merely found a new world. We have unlocked a door, one that opens onto a past we never imagined, and perhaps a future we are unprepared to face. Within the scientific community, these revelations have sparked intense debate. Traditionalists argue for caution, invoking the time-honored principle. Extraordinary claims require extraordinary evidence. Perhaps the data are misinterpreted, they say. Perhaps quantum AI, for all its brilliance, is overfitting the noise, building castles in the static. Yet the AI's statistical certainty is overwhelming. The gravitational modeling is airtight. The object's mass, motion, and signature persist across models, instruments, and time. Meanwhile, a new generation of thinkers embraces the mystery. They argue that our models of the solar system are outdated, built on assumptions of symmetry and simplicity that no longer hold. Why shouldn't there be rogue planets, captured wanderers, or artificial remnants drifting through the void? The solar system is not static. It is alive, shaped by forces we are only beginning to comprehend. As the debate rages on, teams across the globe are mobilizing. Space agencies are drafting proposals for new telescopes dedicated to the search. Private firms are sketching plans for small, fast interstellar probes, automated explorers that could confirm the object's nature before it slips back into darkness. The urgency is real. With each passing year, our aging spacecraft grow weaker, our data windows narrower. We are on the cusp of touching something immense, something that might fade forever if we hesitate. And this is not just about one object. The broader implications of the discovery are transformative. If quantum AI can uncover a hidden giant in our own backyard, what else might it find? What forces lie hidden in the cosmic shadows, encoded in patterns we've failed to see? Could other civilizations have seeded clues? Technological fossils, waiting for us to reach the level of sophistication needed to find them? Could the cosmos be filled with structures invisible to the naked eye, but obvious to an intelligence trained to read spacetime itself? This moment marks not the end of our search, but its rebirth. For centuries, we believed we had charted the solar system's boundaries, that its planets were counted, its mysteries resolved. But the universe has never been so easily tamed. Every answer gives birth to more questions. Every new light casts deeper shadows. In truth, we stand at the edge of a vast, uncharted frontier. Whether the object is Planet 9, a black hole, or something even more incredible, it changes everything. The James Webb telescope has lifted the veil, and our quantum minds have begun to hear the whispers beyond it. The question is no longer whether Planet 9 exists. The real question is, what else is out there waiting for us in the dark?